Work on some progress we made over the last 6 months or so. So there's evidence for anomalies. I'm most interested in excess heat. I'm also convinced that if you want to figure out the theory, you need an experiment that's easier to diagnose. The collimated X-ray and gamma emission experiments, I think, are suitable for this application. I'm interested in up conversion and down conversion, and I've put in a lot of effort on models for that. That's not what I'm going to be focusing on today. I'm interested instead in the coupling between the vibrations and the internal states of the nucleus. But as was mentioned by Florian, the down conversion, we've got a large nuclear quantum. I'm of the opinion that this large nuclear quantum gets split up into a very large number of much smaller quantum. Conceptually, it's simplest just to write a lot of arrows and think of this as down conversion. The numbers, the math favors, instead of having this get divided up directly, that it converts to excitation in metastable nuclei, such as the 90 kilovolt transitions in the iron and the silver isotopes. Because there's very little in the way of observables for the D2 to helium-4, you've got nothing energetic coming out. It's hard to be sure what's going on and prove mechanism. On the other hand, if you can do excitation, then
эксперимент Карабута, он повторял. Карабут умер.
You can actually produce it. So you can put in the vibrations, get out X-rays,
Хороший такой парень, он
neutrons,
забухал. Ну, как
the model
сейчас,
has two parts, as
называется
I
лифт.
mentioned,
Живот.
up conversion, down conversion, but then also coupling between vibrations and nuclei. This was first proposed by our group in 2011. We've done some calculations on it. The idea is to put together an overall model which can account for all of the anomalies systematically. And for example, for excess heat production, as I explained in ICCF 17, we actually get quantitative agreement between the experimental rates for excess heat production and predictions from these kinds of models. We're interested in, so we have a model, and what we'd like to do is to arrange for specific tests for pieces and parts of the model so we can be sure that it's correct, or if it's incorrect, we bury it on the back. We'd like to gain confidence in it. So what I'm going to do is I'm going to talk a little bit about phonon-nuclear coupling. So Florian went through the arguments briefly. I'll be a little bit less brief. The basic idea is that if you start out with a relativistic model, in this case, I've included external field coupling for electric field and for magnetic field, but I'm thinking of neutrons and protons in the nucleus. If I introduce center of mass and relative coordinates, then I can describe the model for a nucleus, the neutrons and protons in the nucleus, in external electric field and external magnetic field with a Hamiltonian like this. The problem of